Welcome to the sterile, high-tech heart of General Atomics, where the world's most advanced unmanned aerial vehicles are born under the glow of brilliant white, LED lighting. Within these walls, the mq9 Reaper and RQ-4 Global Hawk take shape, emerging from a perfect marriage of automated robotics and elite human engineering and precision. The process begins in the cold storage, where ultra-thin carbon fibre layers are kept at precise temperatures to maintain their structural integrity before the complex fabrication starts. State-of-the-art laser systems then carve the composite sheets with micrometric precision, ensuring every single component fits perfectly within the drone's complex, aerodynamic and lightweight structure. Highly skilled technicians meticulously hand-lay the carbon fabric into massive moulds, carefully smoothing out every imperfection to ensure the fuselage remains incredibly strong yet exceptionally lightweight. A specialised vacuum process then seals the layers, removing all trapped air to create a solid, unified structure that can withstand the extreme pressures of high-altitude flight. For the Global Hawk, these moulds are massive, reflecting the aircraft's enormous wingspan, which allows it to loiter over target areas for more than 30 hours straight. Every curve is verified with digital precision, ensuring the aerodynamic profile matches the theoretical design to within a fraction of a millimetre before moving to the oven. The components are then moved into the autoclave, a giant pressurised oven where heat and extreme pressure transform the soft fabric into a rock-hard, high-strength aerospace shell. Inside this industrial crucible, the chemical bonds of the resin are permanently forged, creating a composite material that is stronger than steel, but much lighter than aluminium. And as the mq9 fuselage emerges, it is no longer just cloth and resin. It is a unified structural masterpiece, ready to carry the world's most advanced sensors. Quality control is absolute. Robotic ultrasonic scanners probe deep into the composite structure, detecting even the smallest internal voids or cracks that could compromise the mission's success. While the skin is composite, the internal bones are often made of titanium. High-speed CNC machines mill these critical parts with a continuous stream of cooling fluid. And every metal fitting must meet rigorous aerospace standards, being shaped and polished until they are perfect, ensuring the aircraft can land safely on rugged, unpaved runways. Drilling into composites requires diamond-tipped precision. These holes will soon hold the high-strength fasteners that join the wings to the fuselage, creating a singular, unbreakable flying machine. Every single part, no matter how small, is hand-inspected and logged. In the world of high-altitude surveillance, there is absolutely zero margin for mechanical error or material failure. The factory floor is a symphony of automated production, where advanced robotics and digital manufacturing work in harmony to produce the components of modern aerial warfare. The wings are the most complex parts of the structure, designed to provide maximum lift at high altitudes while housing the fuel and the heavy weapon hardpoints. Human assembly begins where the robots finish. Technicians align the heavy structural ribs, carefully securing the backbone that will support the engine and the mission-critical sensor suites. The drone's nervous system is a complex web of thousands of wires. Each one is hand-woven into a harness that will transmit data and power across the aircraft. Installing the avionics harness is a task requiring extreme patience. So one loose connection could mean the loss of a multi-million-dollar aircraft or the failure of a mission. The heart of the mq9 is the MTS sensor ball. This sophisticated turret houses infrared, laser and daylight cameras, allowing operators to see clearly from miles above. Mounting the sensor turret is a delicate operation. This eye in the sky provides the target tracking capabilities that make the Reaper a formidable and precise tactical asset. Next comes the power plant. The Honeywell turboprop engine is lowered into the tail, providing the reliable thrust and electrical power needed for long-endurance missions around the globe. Gold-plated connectors ensure perfect signal conductivity. These interfaces link the engine's digital brain to the central flight computer, allowing for precise remote throttle control and monitoring. For the Global Hawk, a powerful Rolls-Royce turbofan is installed. This engine allows the drone to cruise at 60,000 feet, far above commercial air traffic and weather. The central processor is the brain of the operation, managing everything from autonomous flight paths to the complex encryption needed for secure satellite communications and data links. Thermal blankets and shielding are installed to protect the sensitive electronics from the extreme cold of the stratosphere and the electromagnetic interference of modern combat environments. The scale of the Global Hawk becomes apparent during wing mating. These massive structures, wider than a Boeing 737, are moved into position with high-precision hydraulic lifts. Laser guidance systems ensure that the wing and fuselage are aligned with sub-millimetre accuracy. Even a tiny misalignment could cause catastrophic instability during a long-range flight mission. Massive high-strength pins are driven through the joints, permanently mating the wings to the airframe. This joint must carry the entire weight of the aircraft during flight. The landing gear is then bolted into place. These robust systems are designed to absorb the impact of landing, with a full load of fuel and precision-guided munitions. The tail assembly is added next. The Reaper's signature V-tail design provides both stability and control, while reducing the aircraft's radar signature from the side and rear. Flight control surfaces are tested for the first time. The smooth movement of the ailerons and flaps is critical for the delicate manoeuvres required during takeoff and landing. So the assembly hall is a hive of activity, as multiple airframes reach their final structural configuration, ready to be outfitted with their secret specialised mission equipment. The massive SATCOM antenna is installed in the nose. This powerful dish allows the drone to be piloted from the other side of the planet via satellite links. Beneath the fuselage, the synthetic aperture radar is mounted. This system allows the Global Hawk to see through clouds, smoke and dust, providing high-resolution imagery in any weather. With the structural assembly complete, the aircraft silhouette is finally whole. It stands as a testament to modern aerodynamics and the power of remotely piloted technology. Every surface is cleaned and inspected for aerodynamic drag. In the world of endurance flight, even a small speck of dust can affect the efficiency of the wing. So the aircraft now enters the paint booth, where robotic arms apply a specialised radar-absorbent coating that helps the drone remain nearly invisible to enemy detection systems. This isn't ordinary paint. It's a complex chemical formula designed to scatter radar waves and withstand the extreme temperature fluctuations found at 40,000 feet above sea level. After the paint cures, the protective masking is removed, revealing the pristine optics and sensor windows that will serve as the eyes for the remote pilot and analysts. The drone is then connected to a diagnostic suite. Thousands of lines of code are verified as the software is synchronized with the hardware for the first time. For the Reaper, weapon systems integration is verified. The hard points are tested to ensure that Hellfire missiles, or GBU bombs, can be released with pinpoint electronic accuracy. Every mechanical actuator is cycled hundreds of times. This ensures that when a command is sent from thousands of miles away, so the aircraft responds with absolute mechanical reliability. Final system checks take place in a controlled environment. The aircraft's electronic signatures are measured to ensure they meet the strict requirements for stealth and communication security. Engineers monitor every bit of data, checking for any anomalies in power distribution or signal latency that could indicate a potential problem during a real-world mission. Navigation lights are activated, signalling that the drone's electrical systems are fully operational. This is the first sign of life for the newly completed aerial hunter. Even the thickness of the paint is measured. Precision is paramount, as variations in coating thickness can affect the aircraft's radar cross-section and its overall mission survivability. Communication links are stressed to their limits. We ensure that the command and control signal remains robust, even in environments with heavy electronic interference or jamming attempts. So final mechanical checks include the landing gear cycles. The flawless operation of these doors is essential for maintaining the aircraft's aerodynamic efficiency and stealth profile during flight. The hangar doors finally open, transitioning from the controlled factory environment to the real world. The mission begins here, on the edge of the vast California desert. A tow tractor carefully guides the mq9 Reaper onto the tarmac. For the first time, the aircraft feels the heat of the sun on its fresh grey skin. Following close behind, the RQ-4 Global Hawk displays its massive wingspan. It is a giant of the upper atmosphere, ready to begin its silent, high-altitude vigil. The final touch is the application of the US Air Force markings and serial numbers. This officially inducts the aircraft into the world's most powerful aerial fleet. Standing together, these two platforms represent the pinnacle of unmanned technology. One is a precision hunter, the other a tireless sentinel, so both essential to modern security. The Reaper's engine roars to life. The propeller becomes a blur of motion, generating the thrust that will soon carry this aircraft to its station miles above the Earth. The raw power of the turboprop engine is evident as it kicks up dust and vibrates the ground. Every system is now at peak performance, ready for departure. As it taxis toward the runway, the remote pilot in the cockpit miles away feels the response of the aircraft. The connection is seamless. The machine is ready. The mq9 and RQ-4 are no longer just products of a factory. They are the eyes and the reach of the nation, the silent guardians of the sky.